Hey guys, are you ready for round two of trigonometry? Trigger what? All right, we're going to look at how to do this in the calculator today. So if you grab your calculator or get Desmos ready, I'm going to show you some really important stuff you have to do with your calculator before we get started. All right, cool. So if you've got your calculator, if it's a TI-84 or something similar, you're going to find the mode button and you're going to have to make sure that calculator is in degree mode before you do anything else. Do not start doing any math problems until you put your calculator in degree mode. It does not automatically default to degree mode. So anytime you clear your memory, you're going to have to make sure you switch it back. So you see the button that says mode, and then you push it, and you've got that third option down. You want to change it to say degree. All right, what about Desmos? If you don't have a TI, that is totally fine. You can use Desmos for this too, but you have to change it to degree mode as well. So if you're in Desmos, find that little settings wrench up in the top right corner. Make sure you hit it, and at the bottom, there's radians and degrees. So you want to make sure that that green highlighted degree is showing up at the bottom. So everybody make sure you are in degree mode. All right, let's test it out and see if you did it correctly. So what we're going to do is try it out with one of these special right triangles that we already know. Okay, so if I give you a right triangle that has one leg with a 5, a reference angle of 60 degrees, and a hypotenuse of 10, we can use cosine to check out this relationship. So my first question is, what is the fraction? Let's see what you remember. What is the fraction that represents the cosine of 60 degrees? All right, good. That's going to be 5 over 10. So the cosine of 60 degrees is the same thing as 1/2 or 0.5, which means if we type the cosine of 60 into our calculator right now, it should tell us that it's 0.5. If you don't have the TI calculator, you should be checking it out in Desmos too. Just make sure that your degree mode is working for you. Here's what we're going to do in Desmos, okay? We've got these trig functions, sine, cosine, and tangent. You can find them by opening the keyboard, hitting that functions button, and then it's going to automatically be on that first tab called trig. So if you need to do sine, cosine, or tangent, you can select them there. On your calculator TI, you have a button that says sine, cosine, and tangent right in the middle. Okay, so you can also just type in Desmos the letters COS for cosine or TAN, and it's going to pop up automatically with a place for you to write that degree measurement. So cosine of 60 is 0.5, and this is what it looks like in Desmos. All right, if you did this with me and you actually got 0.5, then your calculator is correctly set to degree mode, so we are ready to rock and roll. Okay, so one more time. We talked about this in the last video, but why do we need trigonometry? Trigger what? Okay, so I've got an X on one side, nothing on the other side, and a 5 labeled for one of the legs. That's all I know. Can I use Pythagorean theorem? Okay, no, you cannot use Pythagorean theorem for this. Good job, because you don't have enough information. You don't know what the second leg is, and you also don't know what the hypotenuse is. There's no way to solve for x using Pythagorean theorem. Okay, so what do you do instead? Well, if the 48 degrees is the reference angle, then what are those other two sides going to be called? So let's start with worrying about that x. If I'm at a reference angle of 48 degrees and I look at x, what did we call that? Okay, good. That's called the opposite side. Across from the triangle, that's your opposite side. All right, what is the 5 called? Okay, awesome. That's going to be your adjacent side. So you've got the opposite and the adjacent. All right, then your next goal is to pick out a trig ratio. Whoops. Remember, we've got 3 of them. So your choices are sine, cosine, or tangent. Do you remember so, ka, toa from our last video? That's how you can pick this out because we have the opposite and the adjacent side. Which one are you going to pick? Okay, hopefully you said tangent. Yes. So if we set up a trig ratio that says the tangent of 48 degrees, what is that ratio going to look like? What is the fraction that goes with the tangent of 48 degrees? Okay, good. Tangent of 48 degrees is the opposite over the adjacent leg. So we've got an equation now that says tangent of 48 degrees equals 5. Okay, perfect. So now that your calculator is already in degree mode, go ahead and type in tangent of 48 and pick out which one of these decimals your calculator gives you. All right. Oh, I covered it all up. You should have gotten 1.11061251 I can't even say it that fast. Did you get that decimal? If not, maybe your calculator is still not in degree mode. You better go back and rewatch so that you can fix that. All right, cool. Now, think about this as an equation. You just took the left side of the equation that used to have the word tangent, which is kind of hard to solve an equation with a word in it, and you changed it to a number value, right? So now it's 1.1106125148 okay, equals x over 5. So how do you solve this equation? Well, you've got x divided by 5. What is the opposite of dividing by 5? All right, so we're going to multiply both sides of this equation by 5. And that's going to give us the final answer for x. Type it in really quick. Pick out which one of these decimals you got. All right. Did you get 5.55306? Okay, good. Now, the fastest way to type this in, and I'm going to highlight this really quick, is by actually keeping this tangent of 48 values stored in your calculator and then multiplying it by the times 5 instead of converting to a decimal, because I don't want you to round it off. So I'd rather we just leave tangent of 48 degrees times 5 to give us a full value. Okay, so what does this mean? This means we just found the length of the leg of the triangle where it was labeled X. So this guy right here on the side is approximately 5.5 inches, yards, meters, feet. I don't know. They didn't tell me for this one. So that's how long the side is. Congratulations! You just used your calculator to solve a trigonometry equation. Wasn't that bad? Let's try some more. All right, so in this picture, if you have a 29-degree reference angle, what are the other two sides called? Let's talk about that X first. What is X called in this picture? Okay, so the X is the leg that is adjacent to that 29-degree angle. So that's going to be called our adjacent side. What is the 7 called? Okay, the 7 is across from the right angle. That's the hypotenuse. Remember, you can't change the hypotenuse of a right triangle. It is always across from that 90-degree angle. It's also always the longest side of a right triangle, no matter what. So you've got those two sides. Which one of these trig ratios are you going to pick? You've got sine, cosine, or tangent, and they gave you the adjacent leg and the hypotenuse. Don't forget, SOHCAHTOA. All right, now I also want you to set it up. So hopefully you picked cosine because cosine is the CAH. Let me write that out, CAH. Okay, and that stands for cosine is the adjacent over the hypotenuse. So now that you picked out your cosine, go ahead and set up a ratio, see what you got. All right, so let's see here. I don't have it. I thought it was there. So I've got the cosine of 29 degrees is equal to the adjacent leg, x, over the hypotenuse, which is 7. I can't remember if my next slide is going to solve it or not, so I'm going to go to the next slide. You can work on solving it. Nope. Okay, so in your calculator right now, I would like for you to click on cosine of 29. Remember, you're already in degree mode, so you should be good to go. How are we going to solve this equation? Well, we're going to undo the x divided by 7, so we're going to multiply both sides of the equation by 7. So actually, the best way to type this in your calculator is to just go ahead and type all of this together, which is 7 times the cosine of 29 degrees. That's going to give you the answer for x. All right, type it in, see what you got. Okay, I got 6.12, which is rounded off a little bit, for x. So that means that the adjacent leg in that picture above has a length of 6.12. All right, let's try a couple more. Now these have been set up all kind of the same, and there's something a little bit different about these two problems that we're going to look at as far as how to solve them. So what I want you to do is look at this first picture. You've got a reference angle of 38 degrees. They have given you the opposite side, and across from the right angle there, they've given you the hypotenuse. So which one of these trig ratios are you going to pick? And let's go ahead and set up that fraction. Which of these is totally set up correctly? Okay, good. So we're going to use sine of 38 degrees for this one. Okay, because remember, sine is so. I'll go ahead and write out my little memorization trick so we can use it for the other one when we get there. SOHCAHTOA. So sine is opposite over hypotenuse. Okay, sweet. So then the opposite side is 5.3 and the hypotenuse is x, and we need to solve this equation. All right, now the x is in the denominator this time. That's what makes this one a little bit weird. So I could multiply both sides by x, but then I'm still going to have x on the other side with the sine of 38 degrees. So what I would actually rather do for this one, and anytime I have x on the bottom, this is going to be my process, I'm going to go ahead and set this up as a fraction as well and cross multiply. So if I cross multiply this, 1 times 5.3 is going to be 5.3. The other side of the equation is going to be x times the sine of 38 degrees. Okay, and I'm still going to have to take one more step to solve for x, but I can see now that since this is x times the sine of 38 degrees, I can just divide both sides by the sine of 38 degrees. Now you notice I have not typed this in to get a decimal yet, because it would be great if I could just not round it off at all. So my final answer is going to come from typing this into the calculator. I actually want to type 5.3 divided by the sine of 38 degrees. That's going to give me an answer for x. If you're still in degree mode, go ahead and try it out and tell me what you get for x. All right, so I typed it in and I got x is equal to 8.61. That is rounded off, and that means that the hypotenuse of this triangle up here is 8.61. Remember, the hypotenuse is always the longest side of the right triangle, so it makes sense that 8.61 is a bigger number than the 5.3. All right, cool. Second one over here. We've got a reference angle up here of 34 degrees. I've got a side over here and a side right here that I don't know. Go ahead and pick out how you're going to set up a trig equation for this. All right, hopefully you picked out tangent. So the tangent of 34 degrees is going to be equal to the opposite over the adjacent. Those are both legs that they gave you in this picture. So remember, tangent stands for opposite over adjacent. Now again, I've got that x on the bottom. So I'm going to give you a second. Video is going to pause when I ask the question. Make sure you work this one out. You can do it exactly the same way we just solved that other equation with your cross multiply steps and pick out the right final answer. Okay, so for this one, I got x is equal to 25.2. In my calculator, I typed in 17 divided by the tangent of 34 degrees. That is rounded off, so the second leg there would be 25.2. All right, so now, what if they want you to find every single missing side and every single missing angle of this triangle? Oh my goodness, that sounds like a lot of work. Okay, well, the first thing I want to do is pick out the really easy stuff. So if I look at the side lengths, they've already got one labeled for me. That's going to be AC, which is 12. So I can go ahead and mark that down as 12. That was too easy. Okay, then I know the angle C is labeled as 35 degrees. I can go ahead and write that one down as well. Okay, then finally I have that angle A with the right angle in the corner, and therefore angle A is going to be equal to 90 degrees. All right, so this is where we get to tie it all together. How am I going to find the measurement of angle B if I already know the other two angles in the triangle? Figure it out for me. Okay, awesome. So remember, all three interior angles of that triangle still add up to 180 degrees. It's still a triangle. So if I take 180 degrees and subtract out those angles, I'm going to get 55 degrees. Okay, now the hard part for this is finding the other side lengths because I can't use the Pythagorean theorem to do that. That was my old knowledge from middle school, right? Pythagorean theorem. Okay, I can't do that anymore. So instead, I'm going to have to pick a side and go ahead and set up a trigonometric equation to solve for the other two missing sides. Now, my favorite trig ratio, don't tell anyone because they'll get jealous, is tangent. So what I'm going to do is go ahead and put an X over here on the side where it says AB, and I'm going to figure that one out first using my favorite trig ratio, which is tangent. So set up an equation for me with that reference angle of 35 degrees and tangent to solve for X. All right, awesome. That's going to look like the tangent of 35 degrees is equal to the opposite over the adjacent. Oh goodness, what is this doing over the adjacent? Okay, so now solve it for me. Remember, multiply both sides by 12. Type that on in your calculator in degree mode. You should get an answer for X. Okay, so for that side, I got 8.4. X is equal to approximately 8.4. Oh, my pen. Okay, so I'm going to take that 8.4 and I'm going to write it where it says AB, 8.4, except this pen doesn't like me today, 8.4. There we go. And then I have one more side to find. Well, guess what? Now you can use Pythagorean theorem if you want to, because you have two legs of the triangle. So if you were going to set up Pythagorean theorem, 8.4 squared plus 12 squared equals c squared. You can solve it like that if you want. Now your other option is go ahead and put a y or some other variable up there for the hypotenuse. Use that 35 degrees as your reference angle again. Pick a different trig ratio. Set up an equation and solve. Either way, this is up to you now. Find the length of the hypotenuse. Okay, hopefully you got 14.65. Notice that hypotenuse is the longest side of this right triangle. As I promised you, it will always be. Okay, so going into next week, we're going to learn how to find a missing angle if they don't tell us enough information to find the angles. The other thing we're going to focus on next week is word problems. And we're actually already ready to set up this word problem because they gave us all the information that we need. Okay, let's read through and see if we can label our picture. First of all, go ahead and draw a picture. It doesn't have to be as pretty as mine. I kind of borrowed mine from the internet. So anyways, just draw a picture of a ladder leaning up against a wall and we'll go ahead and get started. So the new vocabulary word that they've thrown into this problem is the angle of elevation. Okay, well, elevation means, let's think about getting in an elevator and going up, right? And so the angle of elevation from the ground to where the ladder hits the wall is 77 degrees. So this diagonal right here makes a 77-degree angle with the ground. It would be really nice if my pen would cooperate here. 77 degrees. Okay, now the next thing that they told us is that this is a 12-foot ladder. So on the actual ladder itself, I'm going to label that 12. And then finally, the thing we're trying to find is how high up on the wall, which is over here, does the ladder actually reach? So if I kind of outline my right triangle here, the wall is a leg of the right triangle. The ground is a leg of the right triangle, and the ladder is the hypotenuse. So I have a question. If we know the hypotenuse is the longest side, is x going to end up being greater than or less than 12? Okay, excellent common sense. If you said less than 12, that is correct. If 12 is the hypotenuse and it has to be the longest side, we're looking for our answer to be somewhere around 11 something or smaller. Okay, good. What trig ratio are you going to pick to set up this equation from a reference angle of the 77 degrees? Okay, so the sine of 77 degrees is the opposite over the hypotenuse. So if I pick sine of 77 degrees, I would set up my equation opposite, which is x over 12. Go ahead and type that into your calculator to solve for x, and we're out of here. Okay, good. And as expected, it's a little bit smaller than 12. Our ladder is going to reach up to 11.69 feet up the side of that wall. Now, if I'm really tall, I can probably reach higher than the wall, but right there where that ladder hits, that's only going to be 11.69 feet off the ground. All right, make sure that you practice setting up and solving some of these equations, and don't forget, your calculator has to be in degree mode to be successful with these problems.